Hi, this is Dr. Dave again, and now we're going to do the last technology assignment for the project, which is where we're going to figure out which one of the cost functions you have is the best one and which one of the demand functions you have is the best one. So presumably now you'll have a linear cost graph, a linear demand graph, a quadratic cost graph, and a quadratic demand graph. I've just got linear and quad for my cost and demand here, but you're going to have a lot more than that. So I'm going to start and work out what's called the absolute percent error for the linear cost graph. So the first thing I'm going to do is I'm going to go ahead and make a duplicate. And I'm going to give it a new name. I'm going to take out the copy of part. And I'm going to call this the linear cost graph and then put error. Because basically what I'm trying to do is figure out how much am I missing each one of those points when I draw that line in there. So I know what the y value of the points are. Those are listed in column B. So now I need to find the corresponding y values on the line that I have right here. So I'm going to call this my cost estimate. And the way I'm going to do that is I'm going to go ahead and type in the equation of the line, but I'm going to do it at that particular x value, the 1175 or the 1000 or the 1040. So I'm going to start, since I'm doing a calculation, I always start a calculation with equals. I'm going to say 4.55 times, and the x value is this 1175, so I'll click on it and it'll put A2 in its place there. Then I'm going to finish off the formula plus 5561. And remember, I'm getting those off of my graph over here. Type enter, and it's gone ahead and found for the point that's at 1175, which is probably somewhere down in here, it's telling me where it's being graphed and also where it is on the line. Now I need to do that for every single one of these, but there's a little trick that we can use to do it for us. Go ahead and click on that cell again. Look for this little box right here. This is called the fill box. And once you get that plus, hold your mouse button down, drag it, and what that's going to do, it's going to fill all of those cells with the formula that corresponds to the very first one. So if I go down to this next one here, you'll see the formula says equal 4.55, but now it's times A2. Whereas before it had been, it says A3, previously it had been A2, and if I go down to the next one, it would be on A4. So it's gone ahead and done all those calculations for me without me having to do each one of them individually. So I know that there's a point at 11,087, but the estimate on the line would actually be at 10,907.25. So it's a little bit different. But it's not all that different. What we'd like to know is, as a percent, how different is that? So I'm going to calculate out the absolute percent error. And the formula for that is, it's a calculation, so I'm going to start with equals. I'm going to have to calculate the absolute value, so that is ABS. Because I don't care whether things are above or below the line. That would lead to a percent error that's either positive or negative, but using the ABS command there allows me to say take the absolute value. So I'm going to take the cost minus the estimate and the parentheses, so that's telling me how far apart the point and the line are, and then I'm going to divide that using a slash by the cost. Press enter and it gives me that decimal. I want to convert that decimal into a percent, so I'm going to click on it and then go up to the bar here where I see percent, and I'm going to say format that as a percent. So what that tells me is the line is missing the point by 1.62%. That's not very much. I need to put that in all of those cells below it, so I'm going to grab the fill box there, drag it down, and that calculates out how much I'm missing each one of these. Notice that there's one that it's only missing by 0.05%. That's because the point was at 10,571 and the line is at 10,566. So it goes very close. So I can see these things. Some of them are very close to 0. That means the line and the point are almost on top of each other. And some of them are off by a bit. Here's one that's 1.71%. I'd like to know what the average of all of these are, so I know by how much I'm missing on average. So I'm going to use a function here that's called average, and I'll say equals. I'll type the word average, parentheses, and then I'll click on the first number I want, holding the mouse button down. I'll drag it all the way down, and then finish it with a parentheses, and then press enter. So what this tells me is these numbers, if I take the average of all those numbers, it's about 1.16%. So I'm going to move this over a little bit and then type the word average there. So I know what that is. So if you did a quadratic cost graph error doing the exact same thing and you got a lower percentage here, that would tell you those points are going closer to the line. And that would probably be a better fit than this one right here. Let me try the same thing over on the quadratic demand graph. There it is. And the only complication I'm going to have here is typing in that scientific notation there. So I'm going to do a price estimate. And I'm going to have to type the formula in, but when I get to the x values, I'm going to click on A2. So I'm going to start with equals, and I'm going to type 4.17 capital E minus 0.6 times, so a star, and it's going to be 1175, and I'm going to use the caret key above the 6, a 2 to tell it that it's squared. Now I'm going to subtract 0.0229, and I'm getting that from the formula on the graph, times the x value plus 32.6. Enter. You'll notice the number that I got is fairly close there. If you get something that's totally different from that, that probably means you typed your formula in incorrectly. So now I'm going to grab my fill box and drag it down, and it does all those calculations for me. And if you compare them, you can see they're fairly close to each other. One of the things you can do here is see how it's keeping all the decimal values. If you want fewer of them, you can press this button until you get to about the same number of decimal values. So now it's a lot easier to compare them. So now let's do the absolute percent error. And we're going to do it the same way we did before. I'm going to type equals ABS parentheses, so that takes the absolute value of the price minus the price estimate and the parentheses. So that's telling you how far away you are. To convert it to a percent, I'm going to divide it with the slash by the 11.33. Hit enter. Now click on that again. Click on the percent button. So we know that 11.45 misses 11.33 by 1.06%. To do that to all the cells below, grab the fill box, drag it down, and notice there's some not larger percents here. There's a 3.35, but there are also some pretty small ones in here too. Now let's do our average. So I'm going to say equals average parentheses. Click on the first cell while holding your mouse button down, drag it. That selects everything. End your parentheses, hit enter. So what that tells me is on average, I'm missing those points by 1.41%. So if you were to compare the linear demand to the quadratic, and if the linear had a lower number here, you'd probably choose the linear as the one you want to move forward with on the project. So what I expect to see for this one is when we're done, that each one of you that did if you did the linear cost graph, you're going to do the linear cost graph error. And if you did the quad demand graph, you're going to do the quad demand graph error. So I'll see 4 more sheets here with the error for each one of the models that you did. Once you have those, then you can start moving forward and use your best demand function to come up with a revenue function. And then your best cost function, when you combine those together, you'll be able to come up with a profit function. And then you can start asking yourself, okay, at the point 2000, how fast is that profit function changing? That's your goal for this project, is to measure that change.